University. Richard previously worked at the Wolfson Institute in Southampton, and he was also previously a designer for the GBR Challenge and United Internet Team Germany in the 32nd America's Cup, and was a design team member of the Vestas Sailrocket. And the lecture tonight is on the evolution of the America's Cup yacht design.
Thank you very much. Thank you very much for coming this evening. The presentation, I was told, is being recorded to be put up on the website. So if you see me checking my best side, if I can find which one that is to start with, I'm just trying to line myself up with the webcam here. And if you have any trouble hearing me or anything, just stick your hand up at the back, just so I talk loudly enough, just trying to make sure we get what you can hear and what the mic here can hear without too much difficulty. So yeah, the reason I chose the topic, the evolution of America's Cup yacht design and the move from dare we say it, the chimp-like monohull on your left there to the up and flying multi-hulls that we have now is I thought it was a very good example of how our own industry is developed, as well as these multi-hulls, these sailing craft have developed. Some of the things we've been seeing that have happened with that evolution, we're seeing happening in the wider industry outside. So I think there's, although it's of interest in the topic itself, it's also interesting because it spreads further afield than that. But what I'm going to be talking about is how we actually got from this, which was the schooner America, to this, which was the Oracle catamaran, which won the last America's Cup. So we've had the first and the last there, and as you can see in that intervening, how many would it be? 167 years or so, 164 years. There's been some quite dramatic changes, but certain things have also stayed the same in that time. But let's start where it all began. 1851, and it's only been about 70 years since the American War of Independence, and the Americans were quite keen to show off their technology. So they decided that they would build a yacht. They had the design requirement that it should beat all comers, and they were a bit strange in the belief that they might be able to make some money by betting or winning sailing races. Now, you've been reading a lot about the Panama Papers and all that sort of thing. Normally, yacht racing is used to hide money from various tax authorities and that sort of thing. So the idea that you can actually make money from yacht racing, it doesn't happen, or very, very rarely. So yeah, they decided they would head over to the UK and compete in the what was at the time the £100 Cup. This trophy here. Lots of controversy and lots of intrigue. They started off, in terms of their aim of making money, they got off onto the wrong foot, because on their approach to the Isle of Wight, boats had left from Cowes to see this boat coming in and see what she was like, and they couldn't help themselves but race as they came in. And she was dramatically quicker than the others. She had a technological advantage at the time. She had a lot flatter sails than was traditionally carried in the UK, and she was able to have better pointing ability with that, better closer to the wind. And so word got around, and no one was going to take their money for bets. So they'd failed on that front to start with. They had the race around the island, and it was once around the Isle of Wight. Now, there's a bit of controversy happened there because they missed out a mark, apparently. But that was all sort of glossed over. But it wouldn't be the America's Cup if it wasn't a bit of controversy there. And then in typical American sort of hyperbole, once they'd got the trophy and they'd been given the £100 Cup, they inscribed it incorrectly and said it was the 100 Guineas Cup, so it was worth more than it actually was. But that then led to the longest winning streak in sporting history, something like 137 years, I think, with America being holder of the cup. And I tried to sort of put into some sort of split, some sort of a bit like the periods of evolution of man that I showed at the start. What were the sort of the typical periods of that being dominated, and what were the sort of the key events in those periods? Well, once they won in 1851, they took the cup back over to America, and the cup was donated to the New York Yacht Club via a document called a deed of gift. And that may sound, well, what's important about that? I'll come back to that legal document later when I talk through some of the boats in particular, because this 1850s legal document has shaped the design of the boats that we've seen competing in the America's Cup in a way that you wouldn't imagine something like your granddad's will would, or your great-great-granddad's will would. But this was the document which was used to give the cup as a competition between competing yacht clubs of different countries. But it took a while for people to get round to the challenging for it. And in 1870 there was the first challenge. And then pretty much the sequence between 1870 to 2010 was that you'd have sequences of racing, periods of stability where everyone was happy with the rules, they're all racing the same boats. Then you'd have periods of no racing, either things like wars, global economic crises, or court cases resulting by this legal document, the deed of gift, and people challenging that. And you get cycles of that happening and coming up through the history again and again. And as far as I'm concerned, we're going to see another in maybe 10 or 15, 20 years. It's a bit like you never know it's going to happen, or you don't know when it's going to happen, you just know that at some point it will be. Some of the common themes of that period were unsuccessful British challenges. There were people such as Sir Thomas Lipton, famous of Lipton teas, and Sir Thomas Sopwith, both multiple challengers for the Cup. Peter de Savary in the 80s, and all of them weren't successful in winning the Cup. Various reasons why they weren't, often various other agendas. Sir Thomas Lipton wanting to sell tea, Sir Thomas Sopwith more the competition but had the aircraft, and Sir Peter de Savary, he was able to get access to real estate deals that he wouldn't have been able to if he just went over as a businessman. If you go over with a challenging yacht club, different doors open up. So there's always been in that period complaints that the rules unfairly favour the holder. Basically, the way the Cup works is you win it, you write the rules, and that's been the same way since 1851. And it doesn't matter who's won it at every time. All of the challengers have said, "Oh, it's biased towards it," and the person defending it always says, "No, the challengers have the advantage." So that's always going to continue as well, as far as I can see. And right from the start, there's always been complaints that the cost of competing should be reduced, and that's something we still see to the day. It's too expensive. It always has been. There's always going to be complaints about that. But there's also been sort of somewhat negative common themes. It's always been the technologies that are being applied have always been at the forefront of the available technologies. So whether it was America with their sails, they were flatter, but it was also I think different cottons being used, to whether it's a carbon fibre being used in the modern catamarans now. It's always pushing the limits of what's available from modern technologies. And so here we've got a sequence of the boat sort of working round out from the outside and coming into the centre, starting from that first point with America that I just described, and then ending up with the last boat to win the America's Cup, the Oracle catamaran. I'll go through and talk about the different steps along the road list, why they're significant, and what periods they were used for. The catamaran that was used there, that's a 72-foot catamaran, weighs about 5 tons. We'll also talk after that a little bit about what catamarans are going to be used in the 2017 event, for reasons that they found these were just a little bit too much of a step. But starting off up in the top, this is an era that came in really in the 1930s, the J-class era. This was when, as one of the names I was mentioning, Sir Thomas Sopwith of Sopwith Camel aircraft fame, he was challenging for the Cup. On the American side, you had people like the Rockefellers and Vanderbilts, big New York families there that were funding their campaigns. And when we're talking about technology, some of the technologies being used here, and the use of a hot wire anemometer to be able to measure wind strength. I think there was also, these were just starting to get to the point where aluminium masks were being introduced as well and used for the first time. And it was probably with these boats that Sir Thomas Sopwith had his best chance of winning the Cup, but he managed to scupper his chances by not agreeing to a pay rise for the crew. At that stage, the crew, there were a lot of Cornish fishermen, and I know, having grown up in Cornwall, they're pretty tight, but they had to live quite a hard life. They had to leave their fishing and go and do this, and they were only asking for quite a small amount extra, certainly an amount that Sir Thomas Sopwith could afford, but he stood out on principle, and he ended up having to get other crew to crew the boat, and ended up losing, and he reckoned that was his opportunity lost. He could have won the Cup at that juncture. But this period, these boats are still well loved and admired. There's 3 remaining of the J class that are left, but there's a number that have been built to the lines of previous boats, or of boats that weren't actually built, because it was also a period where people were doing tank testing, so the syndicates would maybe tank test 4 or 5 boats, and some of those ones that were historical records are showing, well, they were a good set of hull lines, but they weren't actually built by a syndicate. Owners have been building now recently in the last sort of 5 years, because they want to compete with the old, I say original, there ain't going to be very much left of what the boat was in the 1930s. A lot of it's been replaced. You might have the same lead, and that'll be about it. But there's still a lot of enthusiasm for this class. Following that, we had the Second World War, and then the period after the Second World War, they decided to get going again. They used the 12-metre class. And the 12-metre class, about sort of 70 foot long, and this was sort of, on a personal level, this was my sort of first introduction to it, was seeing the boats of Peter de Savary when I was growing up. Victory 82, I think, was the one. You see that coming into the port in Cornwall. And of the 12-metre class, this one was the real one that lots of people have heard of, because it's Australia 2. This was the boat that broke the winning streak. Okay, this had a revolutionary keel design, unless you're a model yacht sailor, and you've probably been using it for quite a while. But it was a winged keel design. You can't quite make it out under the water, but they painted their keel different colours, so from overhead pictures it didn't appear that anything was different. But basically, they one of the features of the 12 meters was you had quite a lot of displacement. You had to carry quite a lot of lead, and they'd put the lead into 2 large winglets that came off the keel fin. It's a bit like you have on the end of your Airbus wing heading out, except these weren't nice aerodynamic shapes. They were faired, but they were pretty chunky lead weights. This gave the boat more stability. It also meant it was a little bit more manoeuvrable, and was given as being the main reason that the boat was quicker than the American competition. It wasn't the only reason. They too, like the original America, had a different sail plan and different sail design, and their sail designer ended up heading up the successful Team New Zealand Challenge design teams, Tom Schnackenberg. So they had some real key people involved. But this boat, it won that in 1983, and then that took the cup back down to Fremantle in 87, I think it was. Now this is where the deed of gift that I mentioned earlier starts coming in. The boats in 1987, the competition in Fremantle, the Americans were desperate to win it back, and so they competed in a 12 metre, and they did that. But for 1987, the New Zealanders had got involved in the game, and a banker called Sir Michael Fay had been funding the Team New Zealand White Magic or Kiwi Magic campaign, and he looked at the way the Cup was organised, and he decided that actually there was nothing to say that you had to compete in those 12 metre class boats. He looked at it and said the competition for the Cup is bound by the deed of gift, this 1850s document. I can compete in any boat which is legal under the deed of gift. So he lodged what was known as a deed of gift challenge, and he didn't really say what his boat was going to be at the time. He was very sort of secretive about it, and in part because he didn't have to. The wording in the deed of gift was quite loose, so he chose it to be to his advantage. And he started building the boat you can see in the top there, KZ1, which was unsurprisingly, when you look at the size of the people on the boat, known as the big boat. It's a massive boat. I think it was 100 and something foot long, and had these two large wings on the side with the crew would sit on, large lead bulb and a trim tab, large a fin designed by Bruce Farr, one of the most successful yacht designers ever, and certainly well at his peak at that time. And the New Zealanders, because of the way information came out, and because they were a bit ahead of the game, they were quite confident that they were going to win the America's Cup with this, because the Americans wouldn't have time to do the engineering to build a similar boat to this. So the Americans got thinking about it and decided, well, we can't build we can't compete on a level playing field with a boat like this. What can we do? And they said, well, according to our interpretation of the deed of gift, there's nothing to stop us racing them in a catamaran. And in a catamaran with a wing sail, which is going to have far more aerodynamic efficiency than the soft sails. It's lower loading than than having to tension a soft sail into shape. It all looked to be the right way to go. And as soon as they started doing analysis and performance predictions, you know, the cat was just way quicker than the big boat would be. So they decided to have this competition. A lot of this, I've missed out all the legal shenanigans that were going on at the time, because it was like a ping pong match happening. But in the end, the catamaran did win. It beat the big boat, and they basically had to slow down so it was a fair, or it didn't look like it was a complete mismatch, because that was one of the things under the deed of gift, that they had to be similar boats, and it was pretty clear they weren't in performance terms. So. But one of the things about this, historically, you see an awful lot about these two boats, but what you don't see is the British Challenge, which, funny enough, was unsuccessful, but to my mind, it's one of the best boats ever. This was the Blue Arrow Challenge, and the guy who was sort of leading this project, he was my boss when I worked for GBR Challenge, a guy called Derek Clark, and he described this period when they built this boat that he was pretty much fueled on caffeine at the time, because they went from the first conversation about the boat to sailing the boat in 6 weeks. Okay, this is it's a foil stabilised monohull. So basically, either end there, you've got the foil, so it doesn't lift up on the foils, but the foils are giving it the righting moment to be very lightweight and high speed in comparison to what was possible in a monohull. They wanted to be a monohull because it was the only way they were going to get to race the Kiwis. They had to say that they were a monohull, which they were, but they had these foils, so they felt they could compete with the Americans. Unfortunately, they never really had enough time to get the whole thing working. As you can imagine, just getting it on the water and getting it sailing in 6 weeks, and they weren't on top of well enough being able to get the legal things in place to be able to race. So I don't think it ever raced, but it certainly did scare, I think, everyone who sailed it at one time or another, because it was ridiculously quick in certain circumstances, but it was just getting it to stay at those speeds. But yeah, quite an achievement in itself, just putting that boat together, really. But following this, it was generally decided that, you know, it wasn't the best place to have the America's Cup in the courtrooms, and although the boats had been interesting, and although this one, in terms of using foils, maybe giving us a bit of an insight into what's gone on today, it wasn't really the best way to do it. So people said, in terms of the spectacle, in terms of the competition, it was better when we were in the 12 metres. So they came up with the International America's Cup class. And these are much more traditional looking boats. These are the boats I was involved with GBR Challenge and the German team. And they were monohulls, originally 25 tonnes, came down to 24 tonnes in terms of displacement, about 70 foot long. The length of mast, I think the masts are about 35 metres, pretty much same sort of wingspan as a jumbo jet wing that you had in sail area. And these lasted from the first one, I think it was 92 going till 2007, and we had 5 iterations of those. The first one, I think it was in 94 that the Kiwis won it. And that really changed the game in terms of taking the cup outside of America again, and got more life into it, got more teams competing, and the version that we had in Valencia, this was Oracle's boat from Valencia, which was a 2007 event. I think there were 9 teams competing, and an all-rounder harbour, and a great visual spectacle, and everyone was keen to see how it would progress. As I said earlier on, there's always some legal interest. Well, basically, Larry Ellison, who owned Oracle, wasn't happy with how the rules were being written, said it was favoured the defender too much, Alinghi. So he did his own deed of gift challenge. He went back to this legal document, decided what sort of boat you could build under it. And this was Oracle, the trimaran, which competed against Alinghi, which you can faintly make out in the background there as a catamaran. These two boats are absolutely enormous. The technologies used in these, this was real sort of arms race stuff. The trimaran that Oracle were using, in truth, we're calling it a trimaran. It did have 3 hulls, but it was being sailed like a catamaran, really. They minimised the middle hull as much as they could, and it was kind of a bit of a nominal hull there, but it was quite efficient structurally. But these 2 floats you got either side, they had them full with helium bags, and a friend of mine, he was the electronics guy on board, and he got electronics dotted around the place, and he'd have to be going through them, knifing these bags with helium, but then just coming up for air so he doesn't end up speaking like a muppet or something. the distance you see between the boats here, this was pretty much how the competition ran. The Oracle boat was that they'd had more time on the water, done more sailing. They also had a wing sail as well, and they were just far more powered up and performed far better than Alinghi. Didn't really help that Alinghi had their owner on the helm, who wasn't anywhere near as good a helmsman as James Spithill, who was sailing Oracle. But these boats were just way too big to be practical in the long term. Oracle won the event won the best of 3 series, but to just give you an idea of how difficult it is to control a boat like this with this enormous wing sail that it's got, when it was on the mooring at night, the only guy trusted, you had to have someone to look after the wing sail at night, because you don't know what wind's going to blow through, and you need someone constantly feathering it and depowering it. And that guy had an Olympic gold medal. You know, that's the level that was required to keep it there. And one night during the series, they had a real panic on because the wind blew through and it was sailing on its mooring, and they had 2 ribs with, I think both ribs would have had about 3 200 horsepower engines on the back, and they were both going full out flat chat to keep it still, and they'd had it like that for about 3 hours. So as you can see, there was a feeling we need to come back a little bit from this point, and that's where we end up with this, which was the America's Cup 72. That was what the last event was held in. Got a different boat for the next event. We'll talk about that in a minute. But these were a scale back. Lots of the things that Oracle had been taken on. They kept the wing sail because it's looking more high tech. It's more efficient. And also, as these boats get bigger, in many ways, going with a wing sail, you can reduce some of the loads because you can take things through different elements, and you don't need to tension everything in quite the same way because it's got its own structural strength. So there are a lot of benefits in that, but the speed went up ridiculously. Teams touching 40 knots. Certainly with the latest boats have been going past 40 knots. And when you look at the version 5 Cup boats I was involved in, they went 10 knots everywhere, 10 knots upwind, 10 knots downwind. But it was a bit more of a chess game. This was chess game, but speed chess. So a lot faster. The downside of this was having teams that were capable of competing. The technology required to compete at this level was far more. They've got the hydrofoils here to fly the boat, get it up out of the water. The engineering of that is very complex. Carbon fibre structures, you need good builders to be able to build it with lots of CNC machining. Some of the shapes that they were doing were going through. There's S-bend curves in the foils so that they change from being sort of shaped like L's like that to being shaped like V's as they lower them down, so that you can get more lift versus your side force at different times when they're going upwind and downwind. So huge amount of technology gone into these boats, and you really only found that there was Team New Zealand and Oracle that were capable of running at that sort of level. The Artemis and Luna Rossa, they were definitely a step behind, and that was they were the only teams that were competing. So where did we end up from that for the next event going on? Well, basically, that was the AC-72 I was talking about on the left-hand side. Some of you might have seen in the build-up to that event the AC-45s that were competing in Plymouth, and you've seen those. They do the World Series tour that has been going around. The boats that they've finally settled upon for the 2017 were midway in between. Originally they were aiming for a 60-foot boat, but now they said it's going to be a 48-foot boat, so not that much bigger. In fact, I think the mast is a little bit smaller than the AC-45. They've done this in the justification of reducing size to save costs. very often it doesn't really save cost changing back. I mean, it does make it easier in terms of logistics down to that levels. I'm not sure if the 45s definitely were, I'm not sure if the 48s are, but you can get things in a container so you can ship them around a lot easier if you want to do tours. That makes quite a big difference. But in terms of the big thing that you have with costs is just the number of people you employ. If you've got a bigger team and you pay them more, it costs you more, and that's the biggest driver. When people say, oh, we could change the boat, it'll reduce the cost. Generally, it's employment costs which are the biggie. The other big difference has been that whereas previously lots of designers were all working out what the best shape could be and what the best sails would be, sail shapes, now it's very much a one design package that you've got. You've got the shape is defined, it's given to you, you've got to build it within quite high tolerances. But you do have an influence on what you do with the structure structurally, and particularly with the wing, how that deforms under load because of how you've set your structure up. That's going to have a big input in performance. So although the shape's been given, you've still got some control in terms of what your overall performance will be, but that's by how you change the structure. The big thing to notice though is this is Ben Ainsley's boat for the AC 48 version T3, the one they've just launched recently. The all-up weight of this is 2,500 kilos. When you compare that to the version 5 monohulls at 24 tons, so there's been massive reduction in weight in going to it, and this is why they're able to achieve those speeds of close around 40 knots. So there we talked about the changing. What's really been driving one of these? Well, primarily a lot of it has been the importance of the visual spectacle of the cut. Everyone likes to have an event that people want to see. They want this big impact, so they wanted things to be big. That's why they started off with this AC72. The practicalities of that have sort of wound everyone back in, and that's happened the first time in that they proposed it to be a 60-foot boat for the 2017 Cup in Bermuda, and now they've come back again to 48 foot just because of this cost justification. But the driving factor to have stayed big and to keep it looking high tech was this visual spectacle. But that leads into the next one. They had to generate money from somewhere. You know, you've got to have something that looks good for people to want to sponsorship, and that's what's funding all this technology. And also the final one that's led a bit of the progression is in many ways people are becoming more exposed to other high-speed sailing. When the America's Cup first went into the monohulls the version 5, the IACC class, they were multi-hulls with sort of a bit of an offshore phenomenon, but now with various sailing circuits that are going around, people are used to seeing as spectator sport high-speed monohulls, so it was a bit hard to argue it was the premier event when you were going that much significantly slower. But all this change, all this evolution, how's it affected the designers? So in terms of what would a designer do for a monohull that's become different with these multi-hulls? Well, a big one has been that tank testing has been replaced by CFD. When I was involved with the America's Cup, this is one of the models that we tested in the tank. It was our replica of the Alinghi hull form at the time. We'd spend vast amounts of money and lots of tank test models being built just to hone that design and to get that best possible designing. Now that they're into foiling multi-hulls, well, you don't really have to worry about your wave drag because it's not in the water. You've only got the foils to worry about, and because the Reynolds numbers are so high, well, you're better off doing them in CFD anyway. So that's completely changed. I don't doubt any of the teams will do any tank testing at all for for this America's Cup. Team New Zealand did some last time, and that was just to look at the behaviour in seaway. It wasn't for resistance. It was all being done with CFD. This model here, you can see, looking closer, you might be wondering what this strange arrangement is. It looks a little bit like a TV aerial. Well, one of the things that we're interested in at the time was how do the loads imparted by the rig affect your overall resistance. So we rigged this wire up with a bottle screw and tensioned it so we could deflect the boat by the amount that it would get deflected under the sailing loads when you pull on the backstay and you've got the forestay tension. And the difference in resistance was greater than what we would look at between an LCB variation or a prismatic coefficient variation. So it really drilled home the importance. It was the most significant difference we saw out of all of our designs, was just how is it under load. It really brought out the importance of getting your structures right, so you kept your waterline length, as that's what you were losing effectively, is the bow and the stern came up as it deflected. And although it's not an America's Cup boat, it was sort of the best picture, I thought, to show what the playoffs were in the monohulls. It was always how much stability could you get compared to the resistance that you had. So there was always this aim to get as much lead as you could in the keel, but be playing with the beam to reduce that, so that you didn't have, you wanted some stability from the hull, but you wanted most of it to be coming from the lead. And this game was what was being played through the VPP. We'd be assessing different configurations. Now with the multi-hulls, well, it's done in a very different way. You're not looking at the hull to control your stability versus resistance. You're looking at how you're controlling your rig through the packages that you've got, where your centre of effort is changing as the rig stays up, because the hulls are basically where it's just the foils that are in the water that you've got to worry about. Back in the days where I had hair, this was me in the wind tunnel, and we would do quite a lot of testing on the appendages. We were looking at the flow around the keel on this one. Well, that's all been replaced by CFD. There's no great need to go into these experimental facilities. That was in a wind tunnel in Stuttgart, the Mercedes-Benz wind tunnel, and it's right next door to the VfB Stuttgart football ground. And if they turn the fan on full pelt, the lights in the stadium go out because there's not enough power for both. But yeah, this was part and parcel of doing America's Cup testing. You'd also be doing wind tunnel testing for your sails, and that's been replaced by CFD once again, primarily because of the speed, but also primarily computing power available, and also reliance in the accuracy. These are some of the CFD work that we did when I was working for the Wolfson unit. For the Prada team last time, we helped them set up a system whereby we would, they basically just emailed their different geometries of sail and of wing configuration, and we set it was an automated system that would set those geometries running on the supercomputer we had at the university, and then would send them the results back. So we were doing lots of work for them or in cooperation with them, and all I was doing was checking that the on light was on the computer, because it was all being done visibly. They were doing all the interpretation of the results. Once we got it started, it was for them to have a look at all the data and do the interpretation. I think that's how most teams have gone now. They don't subcontract anything out anymore. They keep it in-house, and the computing resources to do this sort of calculation have become far more readily available. You can use Amazon. They've got their own things that they're using, their servers that computing power you can buy into and set up your own supercomputer effectively just through an Amazon account, and then stop it whenever you like, so you're not paying for it, and you're not paying for someone to look after it when you're not using it. So these things have massively changed as with the evolution. I've mentioned before the velocity prediction programs. This is where we're trying to balance the aerodynamic forces with the hydrodynamic forces, and it was where a lot of time was spent in the monohulls, and it was one of your design arbitrary tools. You'd be able to say, well, if we make this change, we can see how much the boat will speed up. The big difference that's been made in this area is that now you've got to consider vertical motions. It's become far more complicated. You've also got dynamic modelling going on, looking at how the behaviour is changing as the boat moves and gets up onto the foils, and that's quite a significant difference. It's also makes the VPPs that they're being used real specialist tools. It's not like they would use the generic tools that are available to other yacht designers in the industry. One of the other points, but we see it a lot in general yacht design as well, and it happened at each stage. It becomes interesting to see how much CNC manufacture and solid modelling of CAD modelling is becoming more the norm compared to most of the early, certainly the early monohulls in the IACC class would have been done just AutoCAD drawings. Lots of the drawings on this boat. This was the German boat, that's me just by the skipper there, were done in some bits of 3D modelling, but an awful lot in line AutoCAD. And if you look at this pillar here from the Harkin one, look at the design of that, and we compare it to the New Zealand one here. It's going to be a bit hard for you to make out, but basically you can see that whereas it was a solid block and it had quite a large windage, now that they're going faster, they've changed the design of it so it's two bike forks, two aerodynamic forks. That it's the grinder for pulling in the sails, and the tooth belt will go inside each one of those forks rather than inside a solid object that it was before. So that's only been possible because there's more access to CNC machining to be able to make quite a complex mould like that. There's more use of solid modelling going on, and this is something that you see just in that one item on the boat. We could probably pick another sort of 10 or 15 points that you'd see the difference between the two pictures of where that detail is coming in at every level. An interesting one with these ones as well was particularly with Team New Zealand, how much rapid prototyping they were doing, particularly guys like the electronics guys. You've always got lots of electronic things, and you need to be able to make a bracket to hold a readout or something like that. It was always a boat builder fairing a bit of foam. Now it's just someone would print it on a 3D printer. They bought one for about, I think it was $2,000 or $3,000 for this cup, and they used it for about 2 weeks and then went out and bought a $30,000 one. They were so impressed with what they could do and how much they were using it all around the boat. But with it, unfortunately, comes some other elements. It was always said beforehand in the monohulls, the boat should just be able to make it to the finish line in the last race. And you sometimes get boats with structural issues going on, Young America there. Fortunately, in the whole of the IACC class, there was only one fatality sailing the boat, and that was due to someone replacing with a sub-quality product that they weren't supposed to be doing, an item on the boat, and someone got hit on the head. The picture down here is unfortunately the wreckage of Artemis, which the British sailor Andrew Simpson was tragically drowned in. It was this event really that made people think, well, no, that requirement isn't what we should be holding. When the things are happening at this increased speed, then the risk of someone dying or serious injuries is far greater. And so we're going to have to be more prescriptive, which is where some of the elements of design and some of the giving people geometry so they can focus on doing other elements and not getting sidetracked into parts of the design. They can focus on keeping the boats structurally sorted. In many ways, so the requirements that what makes a winning boat haven't really changed. It's still going to be who gets the most effective time on the water. That's always was said with the monohulls, that the team that was best with the time on the water got the most time on the water. They were generally the team that won the America's Cup. That still stands, if not even more so, when you've got something as complicated as a foiling craft to handle. Understanding the equipment you have and how to use it, that definitely happened in the last Cup. You could see Oracle learning their boat as they were in the competition, and they understood, made some subtle changes, and part of that was in getting details right. There were just some slight changes they need to make to a foil, and they were suddenly going from being able to jibe without the boat touching the water, and so getting quite significant speed differences. What can we expect in the future? Well, I thought it was a good way to look at the future. If you look at what was going on in the past, in '92, when the monohulls for the IACC class had their first competition, the speed sailing record was held by Yellow Pages Endeavour. It was 46.52 knots. And it was, this is Il Moro de Venezia, the Italian entry for the Cup. I think that was the first boat, actually. Il Moro was the first ICC boat. They don't look anything like one another. They look like they're coming from different planets. But if we fast forward to 2013, and there's Vestas Sailrocket, which is the current world speed sailing record at 65.57, I think, can't quite remember. There's way more similarities between this and the America's Cup craft than we had in the previous slide. So in terms of where can this one move in the future, I'd say there's not much difference. If we're just talking about speed, it's already moved towards that technology. There's so much of an overlap. And I think with that one, I'll leave it with, if anyone's got any questions, I'm more than happy to answer.
It's not just the whole design, isn't it? Isn't the whole thing a system of systems? And how do you actually train the crew to, inverted commas, fly over these things? How long does that take?
That's a good question. It is massively a thing of systems. I mean, one thing you saw with the AC 45s when they competed in Plymouth, you could see that Team New Zealand were by far and away the best team in terms of getting speed out of that boat, because when they did a manoeuvre, they would bear away very quickly and pull on the sail as hard as they could, and it got the boat up and flying. And so it took the other teams a length of time to catch up with that. In terms of how long does it take, it's completely dependent on the sailors you've got and what structures they have in place to do that. One of the things Team New Zealand were very focused on last time were the time on the water was limited, so they did a lot of time practicing manoeuvres in the shed with the rig down and doing that. One of the things that BAR have invested heavily in, we've seen the benefit in the Formula One world in terms of having simulators and taking a bit of the gaming technology and bringing that into it. They've invested quite heavily in terms of virtual reality headsets and that sort of thing. So in terms of how long does it take, you don't know till they get on the water and try it. But and it is a case of being how long is a piece of string. the best teams have generally just got they've used that same length of time more wisely. Is what you tend to find the outcome of, and it's interesting looking at the place to look is what the sailors are doing in their spare time, and who's sailing things like international moths where they're getting onto the foiling technology and they're understanding the tactics of operating at high speed, who's sailing in some of the catamaran classes, the smaller catamaran classes. If they're doing that in their spare time, then they've got a better chance of doing it in the job.
You're going off Bermuda.
Yeah.
You can get some quite big swells in that area with relatively low wind. How does that affect these hulls?
Well, basically, if you get it really depends on what they're racing, because often if the conditions aren't safe, then they won't. The race officer won't let them race. So if you've got quite large swells running in, I'm not sure that they'd be happy for them to be racing in that, particularly if it's like weather. With the hulls up flying, sometimes they can contour, so it's not. It kind of depends on what your it depends on what your wavelength to height ratio is really. But also there's an element of we'll see when they start racing there as well. Yes.
I understand the CFD on the monohulls, by the time you got to the end of the IACC, was fairly accurate predicting reality. Obviously there's so much more going on. Now we've got foiling catamarans, we've got fairings and everything else in the hull. Although computing power's got better, the software's got better, how accurate do you think it's actually going to be at predicting performance?
I think it's going to be pretty good, because a lot of it, because it's wind drag, the big parts of it are aerodynamic. In terms of the hydrodynamic forces, the hard bit is looking at when things like ventilation will occur and cavitation will occur, because they'll definitely be pushing those boundaries. And I think in terms of because you've got because it's less wave drag related, I think it'll actually be they'll be reasonably accurate. Things like spray and the amounts of drag they won't have a clue on. I'll bet money on it now. But I mean, they can make estimated guesses. I mean, the trouble is, it starts becoming a bit academic as well, because you never have in the computer what you have in reality. Your wind profile over your height can vary massively, and that has a far greater effect. So people often look at what happens hydrodynamically. We were pretty good with doing tank tests hydrodynamically, but our aerodynamic values for the monohulls were quite poor, and it was as much because we didn't actually know what our input condition was to the sails, and that's always changing, and it's changing as the boat pitches and moves and everything like that. So you never really find out the right answer anyway.
Is there a limit on the number of crew that you can have on board, and what is the sort of optimum number that you think?
No, they do have a limit. I can't quite remember what it is for the 48s. I think it's down to something like 8 or something like that. It's probably it's not even going to be that. It's going to be 6, isn't it? They basically what you tend to find is, you go back and historically, probably the best benchmark is you used to see it with how the navigators changed, because as the cups progressed and you went through another cycle, the navigators were in the gym more and they got bigger and bigger because they were being called in to do manoeuvres. And now you've got the people who are sailing on the Cat, there's no one carried at all. I used to play football with Ben Ainsley and Matt Cornwell, two of the crew, obviously for VAR, and both of those guys are very fit in terms of their level of ability. I mean, they're sort of, they're professional footballer standard. They're not. Matt probably was, Ben not in terms of speed of being able to do something, but in terms of the endurance and how long they could keep going. It's a very high level, and they'll all have to be like that just to be able to power the winches and the equipment and the hydraulics.
So it comes down to power density often, and you've got guys who are now grinding on hydraulic winches. There's no stored power, and so they're able to control what is effectively a massive wing sail. Are there likely to be further improvements in getting more power out for the same power in that you can see as they refine the design over the next few years?
It'd be interesting. I mean, people have looked historically at doing different winch powering arrangements. I mean, back in the 70s, there was a boat where they tried to use the leg muscles of the grinders to power it, and that wasn't really successful because you still got to stand on this platform. So I think realistically, the tooth belts arrangements that you'll have with the harking gear, they're pretty effective. We were always trying to look at how you could minimise joints in the system and get direct drives, and that all that element will be taken into account. I mean, each iteration of boat they'll get more in terms of what they'll be able to do in terms of, yeah, possibly they might be able to get better pumps going in, because I'd have thought actually if you're going to pick on one area, the pumps, if you're having rotary pump hydraulic technology for someone like a winch manufacturer, it's not going to have been as thought through as a commercial other commercial products. So yeah, possibly, but the arguments would always be, I'll just go to the gym more. That would be that's what would be thrown to the sailors.
Is there a danger that as the boats getting more and more high performance, in the last couple of America's Cup, there haven't been that many races that were tight finishes, close finishes, that with the high performance boat there's less boats on boat racing?
There's certainly pretty close moments in the racing going before. I mean, there was the one of the they've had a couple of almost near hits and close actions like that. The problem, there is a problem with that, that like you say, that if you get a gust when you've got these boats, just a slight increase in the wind one side or the other, and particularly if it goes in light winds, that's the worst case, because if you suddenly get a boat that transitions from being stuck in the water to being up on its foils, and it's doing knots faster, tens of knots faster, so that way you can get a big disparity occur. I think in general people would rather but conversely, it gives the person behind the opportunity to catch up potentially in those conditions. So I think certainly speed isn't everything, but it seems to be what people are quite happy to watch. And if you've got a one design platform, you're reducing the scope for speed differences. I don't think you'll ever get away from it, just because if you're on the right side of the course or the wrong side of the course, or you get a gust at the right point relative to the tide, and particularly there were patchy parts in San Francisco, you're going to get a gap, and that's it. You can't really do anything about it. Provided the courses are short enough, they stay in the same helicopter shot. I don't think people will mind, but they're the sort of driving factors.
Is any of this technology going to come into a normal cruiser sailor?
Well, bits of it do, but you just don't see them. Things like the winches, stuff that comes through packages like that with Harken. I think you'll see. I mean, people had talked about it after the last cup. There was I think there was a type of Beneteau that was offered with a wing sail wheel. People have had wing sails floating around since the 1980s. Bob will probably tell me earlier than that, with some that came through Weymouth Speedway, and they never take off particularly, because it's pretty difficult, you know, for your average cruiser sailor, or even your average racing sailor. It's far easier to be able to have something you can wrap up, take it in and get it repaired. It's lighter weight as well, you know, there's not always weight savings when you go. It's so it actually, the sails suits the purpose, but I mean things do spin through the materials, and the some of the materials get tested and they get time on the water, but sometimes that takes a long time to feed back. I mean, you look at it and say, well, Kevlar was an example that you had coming into sales. I think that was actually one of the things that Australia too had as well. They were using Kevlar beforehand, and you've definitely seen Kevlar sales come in, but it takes a longer time till the money comes down, or production costs come down, or other things become more expensive that people say, oh yeah, we'll adopt that. So there will be elements, but I don't and I think you'll see, you know, with the production technologies, there's definitely more CNC machining going on. I mean, that's a general industry-wide thing that's happening, but some of the boat builders have been maybe learnt it from the America's Cup, then they come back and work in it, and the designers get to see how it works in the America's Cup, then they fed back in. So, you know, more of the cruising yacht builders are using CNC in their build processes than work.
You said that the hulls and the shape of the sail are fixed, so those are the only things that are fixed. So there's complete freedom in foils and all the equipment and everything else.
Yeah, the foils are free. In terms of the other equipment that's on board, I think so. I think that I'm trying to remember if some of the hydraulics were spec'd or not. I can't quite remember on that one. That would be about the only part. But the foils are definitely free, and what you do with them is up to you. And so that's where most of the work is being done, both on the structural side and the hydrodynamics of that.
So if we were to enter next year, what sort of amount of money would we require to put it on?
Well, it depends how much we want to pay ourselves. No, I mean that's really hard, because I mean, looking at the moment, Ben Ainsley Racing is probably spending more than Oracle is, because they built more boats. If you're looking at a boat, I can't see, you know, the whole of that package has got to be in the 3 to 5 million a boat. Well, yeah, just the weight of materials and time and labour and everything like that. And then you're going to have people. You're going to have a team of around about. They won't be less than 50 to 100 a team, and it's paying for the infrastructure. At ballpark figures, I mean, you've got to be. You wouldn't want less than sort of 50 million to sort of start with. I would think, at least.
Ben Ainsley's target was 90 million.
Yeah, that's probably right. I think you could do it for less, like I say. But yeah, no, exactly. I mean, that's the thing. I mean, the Kiwis always like to say they were doing things cheaper and they were doing it this way and that way. But in general, you just looked at what they were spending, and they just didn't declare everything that they were spending. But people, because they had money from the New Zealand government, they had to appear that they were giving good value for money. But they just had a whole load of non-Kiwi millionaires who liked their ethos and liked pumping money in, and you just saw the amount of things they owned, and you thought, well, you can't buy that, you can't run that without cash somewhere, so you can't be operating as cheaply as you say.
The Vestas Sailrocket was
Yeah.
a completely different shape. Had cavitating foils and
Yeah.
aerated foils.
Yeah.
Is it likely that, or are they already using aerated foils?
They're interested in it, but whether they're doing it or not, the trouble with it, I mean, Sailrocket was an easier design problem in some ways, in that it was an all-out speed. The big issue with those types of foils is the low speed drag, because basically the foil section is quite is a sharp leading edge and a truncated trailing edge, quite thick. Maximum thickness is at the trailing edge, and so you've got large sort of separated drag if you're at low speed, and you'd have to be pretty sure that you were always going to be above. Well, a good example is Sailrocket 1 didn't have ventilating foils, and that went up to 55 knots with a subcavitating section. So if you get your subcavitating section right, you should be able to. Yeah. So I don't think they'll ever go for them because they'll have to race in the light winds, and then it's too much of a penalty. And the window for when Sailrocket 2 or 1 got taken out, it's a pretty narrow wind race.
But presumably they could change the foils on the legs for the conditions for the racing.
If they allow it, at the moment you can. If they'd allow it, I think you'd definitely see it. And it might get to a point that if they wanted to say, well, let's go for all out speed, and if they start pushing the speed and they start having issues with cavitation. I mean, I say we took the foils on Sailrocket to higher speeds. I mean, one of the easy side, we did that by reducing the lift coefficient, so it was a lower lift coefficient in more area, whereas they're trying to get rid of drag. So controlling their foils and choosing the lift coefficient so that they minimise that will be their big issue, and they've got rate control that they can do, I think.
Sorry. Yeah, Richard, the International Moth design, we've been using foils for quite a while now. They have a system that detects the wave height
Yeah.
and adjusts the foils automatically.
Yeah.
Is there any move to do that with the America's Cup designs?
No, I think this was it came about, the whole foiling thing came about, originally they didn't think anyone would do it, but the Kiwis worked out how to do it without having T-foils on the rudders. So the original Kiwi boat, it was just lifting up on the foils, the main foils. It's slightly favoured compared to the International Moth, because the International Moth is only, 4 metres or 3.8, 3 and a bit, I think it's just under 4 metres. And any sort of slight movement, you've got quite significant pitches with pitch angle variation with quite small physical distances. On a larger platform, that's all damped out a little bit, so the requirement to do that wasn't there. And once they sort of worked out how to do it, they found they didn't need it.
So it's quite critical, the angle, isn't it? They have to keep trimming it.
Yeah, it is for the moths, but that's part of the kind of the downside of a smaller, more variable system, if you like.
So what actually keeps the foils in the water at speed then? Stops the boat lifting right
out. Because when they angle down, they've got V foils on them, and so the foil coming out and it will lift down, and so you get this sort of and you've also got, as it increases closer to the surface, it will lose efficiency. So in truth, it will be oscillating, but it just depends what your frequency of oscillations are. So what they're looking to do is to have it oscillating about a mean, but very small oscillations. So if it rises up, it'll.
So the foils strike me as really a real breakthrough, and it's something that I haven't seen, until the America's Cup boats.
Yeah.
The 80-45 whatever species came along.
No, they've had them. People have been around the scene doing it for years. I mean, back in the Weymouth Speed Weeks, back to the first sort of proper sailing boats were done even back in the 50s. There was Dave Kuiper in the States. The S-bend, the weird shakes are there. Yeah, the first people to start doing that was probably coming out of the trimarans, the French offshore trimarans. And he used to talk to the boat builders for the French team, because they've been being the tri-world, and they used to say, well, yeah, it's fine, but if we have to repair it and we don't have a CNC jig mould and you've got a broken board, it's an absolute nightmare, because you'll never get it to go back through your slot for it. So it all relies on quite high levels of precision, and you've got to have good boat builders who are capable of working at that. More of that's happening now, because with the more that it goes across to pre-preg production, it's a lot cleaner work environment. It's not the old sort of days of get a tub of polyester resin and chuck it in. It's all a lot more controlled. And also, there's so many people with CNC machines out there now. Getting stuff CNC machined isn't the problem it used to. There's people with time on their beds. It's as much engineers building up confidence to take certain shapes and to get the fibres to work in it, because it doesn't make for easy analysis, those sorts of things. So you do have to sort of do your load cases and see how you can get it to work. And often, you increase in computing power and increase in FEA software and better links between FEA software and CAD software, all these sorts of things have all helped this transition to occur.
So what gives you your pitch stiffness? Is that having the centre of gravity behind the main foils and in front of the rudders, so that you've got the restoring moment, is it?
Yeah, I think so. It's basically they're often running at ever so slightly an angle, and it's basically just but it's just finding that dynamic condition and also balancing it with what the rig's doing as well. So yeah, that was the trick. The Kiwis did it. Now they all run with T-falls after the Artemis accident, because once everyone saw the Kiwis doing it, they all tried to do it, because you knew as soon as you're falling you're going to be that much quicker. So the other teams tried to do it, and there was a bit of a worry that actually if boats are going to risk pitch poling and going over, they should have the T-falls on the back to arrest that. So that's kind of been kept in as a safety measure, and certainly makes the whole principle and getting the pitch stiffness right. It's a lot easier. With the Kiwi boat, they were just very good on how everything was set up, to be honest. And they looked at what their forces would be in balancing it.
So, in the last America's Cup, we got to this incredibly dramatic position where the Kiwis had won everything, only needed one more, and then the Americans won everything else. What's the story? Do we know what the story is? What did they do right? Yeah, basically it was a number of things. I mean, they had the big publicised one. They got Ben Ainsley on board and took John Kostecki off. I mean, I don't know on that, in regards with that one, how much of an effect that would have. It does make a difference if boats are more stable and happier, and by reputation, John Kostecki's not the easiest person on the planet, but, so I can see how that would make an effect. But one of the big things they did was they sorted out, they were having a bit of a cavitation issue on one of the foils, and one of the designers just made some very small modifications, just sort of getting the boat builders out with some literally not quite plastic padding but not far off, and just fairing out what had been causing some cavitation, and once they'd sort of got that, and it's also a little bit the sailors really knew they were up against it, so they had to do something, and then once they'd worked out keeping the boat off the water through their jibes, then they'd sort of found their speed with this cavitation fix as well. They had more all-round speed. If anything, I was quite surprised that they ended up being so close in the end, overall, because potentially there was a scope for a massive speed difference. I was told that they decided that the factor of safety on the rig was too high, so basically they were allowed to pull the main in more.
Oh, right. Yeah. No, it can be as simple as that. Yeah. Just
sheet on harder because
It's all
you go
instrumented
faster.
to the end.
Yeah.
With all this high speed, do you get any problem with erosion on the foils?
No,
Because the sea water, especially
yeah.
in a place like San Francisco Bay, is not entirely clear.
No, you probably not is the answer to that. I mean, if you'd get bits of pitting if it was there, but the foils, because the boat's in and out of water so quick and so looked after, it would be solved because, you know, one of the things with it when it happens on a propeller or something like that is because no one has a look at it. It starts happening. Propellers are doing way more revolutions and those sorts of things. So the boat would be out, and if there was a little dink, it would be fired out for the next sail. So and we we looked at it with Sailrocket in terms of whether we would need to go to things like steel or the like to handle cavitation speeds, but you know it was fine with just the carbon. I mean, you're more likely to damage it in handling it, or you know, manual handling in operations than some of that than erosion.
All right. Thank you very much for that, Richard. I think it just remains to thank our speaker in the normal way.